Now comes the fun part. We can start running the API to see how things are working. Notice the route attribute on the controller. It's API/controller, where controller will get replaced with the name of the controller, authors. When we ran the app before, remember that it defaulted to Swagger's user interface. But for looking at the GET methods, it's a lot easier to just browse directly to the API authors URL. So I'm going to change the launch settings that Visual Studio reads, and that's a file in the Properties folder. Since I'm running the Pub API profile, this section right here, notice that the launch URL is Swagger, and I'll change that to API/authors, so that's the default for this first bit of exploration. Now when I run the application, it goes directly to API authors, and the default method of the controller is the GET method that returns all the authors. Since the controller method is only querying authors, not any of its related data, the author objects are only coming back with the ID and the first and last name populated, and the books property will always be empty. Remember, I said that logging has a few default targets for its output. Looking at the debug output window in Visual Studio, you can see the command that EF-Core sent to the database, although it's buried among so much other debug information that isn't coming from the logging. When debugging by way of the Kestrel server, as I'm doing here, ASP.NET Core also outputs logs to a console window. And here's that window. Recall that app settings had some other default logs set up, and that's why you see this hosting info at the top. But then we've got all the warnings from EF-Core, as well as the database command that was sent to the database. Showing the logs in a console window is important if you're using something other than Visual Studio on Windows to build and debug your application. If we were running with IIS Express, there's yet another place to see the logs. And I want you to see that, so I'll change the debug dropdown to IIS Express and then run the app again. And yeah, it's defaulting to Swagger again because I didn't change the launch settings for this profile. I'll just change the URL to point to API/authors, and there's the list of authors again. But back in Visual Studio's output window, now I can drop down the window options, and there's a new one, Pub API-ASP.NET Core Web Server. And there again are the logs. So that's yet another one of the default targets for logging in ASP.NET Core. And while we're here, I will just point out that, by the way, as the controller just selected all the authors, there's the SQL that does the same. Let's get back to the API methods. The default is that GET that returns all the authors, which, remember, is how it was defined by the template. The other GET method allows you to pass along an author ID to just get that one author. I'll toss a breakpoint in there, and again, there's the default. Now I'll just tack a slash and the number 1 at the end of the URL and hit enter. Code queries for that author using findAsync along with the ID that got passed in. Then it makes sure that you do have an object and then returns that object, which ASP.NET Core then transforms into JSON, which is then returned to the browser. Let's see what happens if I use a bogus ID. I'll use 123, which I know isn't in the database. And the output of that is a JSON object with a 404 not found result. There's one last thing I want to do here, which is to show you that you can certainly return shaped results from a controller, but you'll have to add code to handle the recursive data that comes back in the results. I'll modify the getAuthors method to include books along with the authors, and then I'll run the app again. And we've got an error. The most important word is this exception, serialize cycle detected. And you might recall learning in an earlier module how the objects for related data are cyclical. I mentioned at that time that this causes a problem with web applications, and this is the exact problem. It's not an EF-Core problem, and it's not an ASP.NET Core problem, but just a software problem. ASP.NET Core is converting the results into JSON, and as it's doing that, it's tumbling into the cyclical data, and then eventually it just decided there were way too many levels. Because it is so common, there's a very specific fix for it, which we need to apply in the program file. When the code adds the controller to its services collection, you need to add a JSON option for the controller that will apply the fix. Here's the syntax. We'll append the add JSON options method to add controllers. In its parameter, I'll define a Lambda variable and I'll just call it opt. Then we'll configure this option's JSON serializer options dot reference handler with the enum reference handler ignore cycles. So it will understand to ignore all that cyclical data and just send back the core of the results. That will do the trick, and there's really no need to dig into this any further for this course. I'll go ahead and run it again, and there are all of the authors with their books listed. But keep in mind, I haven't yet changed the method that takes an author ID as a parameter, so that's still just returning authors and not the books. As I said earlier, the controller template created a decent stake in the ground, but most developers working with ASP.NET apps might either skip the template completely or immediately do an important refactoring. Using the entity classes directly from the back end all the way to the front end is considered to be an anti-pattern. And now that you've seen the basics of how the template-generated controller works, it's time to refactor it to keep the entities out of the requests and responses from whatever client is communicating with our controller. And there are even more ways to improve on the design when your controllers are using EF Core, but this will be a reasonable start for your EF Core fundamentals. The classes we'll create for the HTTP requests and responses are called data transfer objects and fondly known as DTOs. And because our original classes are pretty simple, the DTOs here won't look much different. However, it's still important for you to understand how to use DTOs with EF Core in the mix. The way this will work when we're done is that we'll use EF Core and the original classes anytime the controller interacts with EF Core for queries, inserts, etc. But when we work between the controller and whatever client is making requests and receiving responses, that will always use a DTO, which means that these controller methods will need to be able to transform entities into DTOs and back. I'll start by creating a DTO that represents how we want the author data to be surfaced from our controller. The author DTO will live in the Pub API project because it's specific to the API, not any other part of our application. But if I were building a front end, I would also include these DTOs there. And again, this DTO looks similar to our author class, except that it's unaware of books. The design of our controller doesn't involve books, just authors. That means there's no need for the author DTO to have a books property. Otherwise, it does look similar with the author ID, first name, and last name with their simple getters and setters. Let's see how that affects the controller method that gets a single author. Notice that the signature has changed. Rather than return an author, it's now returning an author DTO. And I don't have to change the query. That's the interaction with EF Core, so it remains the same. And we still need to check to see if it's null or not. But then, rather than returning that author entity that came back from EF Core, I need to create an author DTO object from the properties of the author returned from the query. And it's that author DTO that I'll return in this last line of method code. Now, I know that I'll need to do this conversion from an author to an author DTO elsewhere. So I'll refactor this and create a little helper method called author to DTO. And that lets me pass in the author and returns an author DTO object. Now in my controller method, my last line of code is just to return the result of author to DTO that are derived from passing in my author object. Let's try out this first refactored method. I've set a breakpoint on the line that returns the author DTO, and I'll run the app. Remember, it still defaults to the original method, which I haven't refactored yet. So in the URL, I'll just add /1 to the end. And now here I am in the getAuthor method where I have my author in hand, and it's time to return the author DTO. So we pop into the helper method, and then that's what gets returned. And here's the output from the method. Because I've returned the author DTO, I no longer have that useless and always empty books property. Next, I'll transform the getAuthors method. The original version had only a single line of code that returned the results of a query for all authors. But now I want to return a list of author DTOs. I could query for authors again and then transform the author list into a DTO list using my helper method. But there's a much more efficient way to do that. Remember, projecting with a select method, we can still have a single line of code. I'm still querying against the author's DB set, but I'm projecting the results into author DTO objects. And finally, I return that list of author DTOs, and here they are displayed in the browser. And again, no books properties anymore. I've also refactored the other methods in the controller. We'll explore those as we debug them along with a delete method. In the download sample code, you'll also find a new controller and a pair of DTOs designed to return graphs of authors with their books.